You flick a lighter and a flame appears in less than a second. You don't think about it. You just have fire instantly whenever you want it. But for most of the story of human evolution, that flame did not exist at all. For millions of years, your ancestors lived, hunted, gave birth, and died without ever once warming their hands over a controlled flame. What did that life actually look like? The answer is stranger and more physically demanding than almost anyone imagines. Start with the body you were given. Every one of your ancestors before a certain point had bigger jaws than you, bigger teeth, a gut nearly twice the size of yours relative to body weight. None of that was decoration. It was industrial equipment, built to process raw food because cooking did not exist yet to do half the work for them. Raw food is brutal to live on. It is tough, fibrous, and calorie poor compared to anything cooked. Chimpanzees today, who eat a mostly raw diet, spend around 5 hours a day just chewing. 5 hours. Every single day. Imagine treating nearly a quarter of your waking life as mandatory jaw labor, just to extract enough energy to survive until tomorrow. The anthropologist Richard Wrangham has spent decades studying what happened when that changed. His research proposes something now known as the cooking hypothesis, that controlled use of fire to cook food may have been one of the most transformative events in the entire human story, reshaping the body itself, not just the diet. But here's the puzzle. Before that transformation could happen, hominins had to survive without fire for an almost unimaginable stretch of time. How long exactly? The oldest confirmed evidence of habitual, controlled fire use comes from Wonderwork Cave in South Africa. The archaeologist Francesco Berna led a team that found burned bone fragments and ash deep inside the cave, dated to roughly 1 million years ago. That sounds ancient. It is ancient. And yet the human evolutionary line stretches back more than 6 million years before that. Do the math and you get a staggering number. For something like 80 to 90% of the time hominins have existed on this planet, there was no fire in their lives at all. No warmth on demand, no cooked meat, no light after sunset except the moon and stars. So how did they make it through the night? Not with flame, with behavior. Early hominins were what researchers call behavioral thermoregulators, meaning they survived temperature extremes through what they did, not what they built. They sought out caves and rock overhangs that trapped daytime heat. They huddled together in tight groups, sharing body warmth the way many primates still do. Thick body hair, which modern humans mostly lost later, provided real insulation against the cold in a way your smooth skin today cannot. And when the sun was up, the opposite problem appeared. Africa is hot, and moving during the day, especially while chasing prey, generates a serious amount of internal heat that has to go somewhere. This is where one of the strangest adaptations in the human body enters the story. The biological anthropologist Nina Jablonski has documented how humans evolved an extraordinary number of sweat glands compared to other primates. Alongside a gradual loss of thick body hair, chimpanzees pant to cool down, humans sweat, and sweat far more efficiently across nearly the entire surface of bare skin. This single adaptation let early humans do something almost no other large mammal in the African savanna could do. They could stay active in the heat of the day for hours without overheating. Why would that matter enough to reshape an entire species? The researchers Dennis Bramble and Daniel Lieberman proposed an answer built around a hunting strategy called persistent hunting. Without spears advanced enough to kill from a distance, and certainly without fire to help in any direct way, early humans may have run prey animals to the point of collapse, not by outrunning them in a sprint. Antelope and other game are far faster over short distances. Instead, early hunters relied on endurance, tracking an animal for hours under the full heat of the day until it overheated and could no longer continue, while the sweating, upright, bare-skinned human kept going. That strategy required a body built for heat tolerance, long before it required a body built around cooked food. So the traits you might assume came from fire, the traits that made humans different from every other primate, may have started forming for an entirely different reason. Survival without fire did not just happen to early humans. It actively shaped them, limb by limb, gland by gland. Still, life without fire came with a cost that never fully went away, even after flames finally entered the picture. Darkness was dangerous. Large predators hunted at night, and without fire to keep them at bay, early humans had to be strategic about where they slept. Elevated ledges, cave mouths that could be partially blocked. Trees in earlier hominin history may have still served as a nightly refuge the way they do for chimpanzees today. Food access was constant labor, not an occasional errand. Raw meat, when it could be obtained at all, often came through scavenging carcasses left by other predators, using simple stone tools first developed by early Homo species roughly 2.6 million years ago to crack bones and access marrow other animals couldn't reach. That marrow, rich in fat and calories, may have been one of the few high-density food sources available before either fire or hunting technology existed to make meat easier to acquire regularly. Every calorie was earned through hours of physical effort, whether that meant walking long distances searching for edible plants, chewing tough raw fibers for hours at a stretch, or tracking an animal for an entire afternoon under a punishing sun. There was no shortcut, no stove, no lighter, just a body slowly, generationally, adapting to make the impossible merely difficult. And then fire arrived, and it changed almost everything that came after it. Cooked food is dramatically easier to digest, it requires less chewing, delivers more usable calories per bite, and effectively predigests tough plant fibers and proteins outside the body instead of inside it. Rangham's research suggests that once cooking became reliable, the pressure driving those massive jaws, oversized teeth, and giant digestive tracts began to ease. Bodies could afford to shrink those systems and reallocate the saved energy elsewhere. Some researchers argue that reallocation may have helped fuel the growth of something else entirely, a brain that consumes a disproportionate share of the body's total energy budget, even at rest. None of this means fire is the sole reason humans became human. The debate among researchers over exactly when and how completely fire reshaped hominin biology is still active and unresolved. But it does mean something important gets lost in the modern picture of prehistoric life. The image of a caveman huddled by a roaring fire is the ending of the story, not the beginning. The beginning was far longer, far harder, and almost entirely fireless. You are still carrying pieces of that fireless world in your body right now, whether you notice them or not. The sweat that embarrasses you on a hot day is a survival tool refined over millions of years, specifically so an ancestor of yours could keep moving under the sun long after an animal beside them collapsed from heat. The relatively small jaw and teeth you have compared to your ancient relatives exist because, eventually, someone learned to make food softer before it ever reached a mouth. You inherited the ending of a process that started with nothing but bare skin, patience, and an unreasonable tolerance for heat. So the next time you flick a lighter and a flame appears without effort, remember what that flame replaced. It replaced hours of chewing. It replaced running an animal into exhaustion under an open sky. It replaced a body forced to do, slowly and painfully, everything that fire would eventually do in seconds. The flame is instant now. The struggle it replaced was not. If this video meant something to you, subscribe. There's more where this came from. I'll see you in the next one. Bye.